Welcome back, data leaders and my dear learners, to Insight Builder channel. Creating and using custom classes in Python. The problem solved by classes. Each application, real-world application, will have different kind of variables. And these variables will have different set of capabilities and functions. In order to implement them inside the programming construct like Python script, you need to create these variables manually every time. This is the problem. So you have to do a lot of manual code for all the types of variables. So you start working on a banking application. There is accounts, there is the bank, and there is the deposit and various kinds of banking applications. For that, each application, there will be different variables. Now coming to IoT application, another example, you will have various kinds of sensors. There could be a temperature sensor, and there could be a sensor that identifies the IR rays coming from the sun. Both are sensors, but the variables and the functions of those variables will be different. Let us understand what is classes first. Classes are basically building blocks of any Python script. Instance of a class is first of all called as an object. Object is basically a copy of the class. You will understand why I am calling it as a copy in a couple of minutes. All the inbuilt data types in Python is actually a class. So there is integer class, there is string class, and there is float class. All these variables have different capabilities. You will be seeing how to create such capabilities for your own custom classes in this video. We have understood what is classes a bit, and we have seen what problems it solves. But now let us come to the answer, how Python solves it. Basically, when a problem has to be solved, when a big problem has to be solved, there is usually an architect or a designer of the program, and the designer designs various templates for the objects or the variables that is going to be used inside the Python program or the Python application. So based on the application, we can either create the this way of creating the variables based on the application is called as top-down approach. So we go to the overall picture of the business application or the real-world application and then create the classes. From now we will call the classes as templates. So we will create the templates of the variables and then we will code it. And the code that is written in Python is actually the class code. Let us go to the next step. In next slide, we see classes in action. So in the left hand side, you see there is a picture of a rocket inside a gray box. Assume that this is like the stamp that we use on the paper, where we put an ink on the stamp and put it on the paper, it will create the impression. Like that, this is basically a stamp. So it's a template. And using this stamp, we can actually create any kind of rocket. You see the rockets this side. You might be wondering how you can actually think that, okay, making a rocket of this type is easy, but how to make a rocket of this type by using this stamp? So that is where the class comes into picture. So this template can be modified the way you want. But at the end of the day, if you look at it, both are rockets, both have certain abilities like launching, turning, moving, and rotating. All these are abilities. Both these rockets will have height, weight, name, and diameter. That is how these are the basic requirements that is required to create a rocket object. So rocket 1 is created using the class, this class rocket, using the name Solum, and given a height of 250, weight of 7,807, and a diameter of 325. It is little thicker, right? And the other rocket, this one is called Prime, with height of 157, with weight of 5,267, and 170 as the diameter. This is a very visual understanding of how classes work. So basically, class is a template from which you create copies of it. If you have imagined, you can actually use Python to work on real rocket science applications also. People do it. You can actually use those same class functions and hide all the complexities inside the class function, and you can create an application. That is how most of the Python libraries are created. So we have understood how the class in action happens. Now let us go further. Let us see how the code of the class is written. To write the code, we need to use the statement class and give the class name. So here it is rocket, and the first and foremost function, this is a function that we use is by the name double underscore, or called dunder init dunder. So double underscore is called as dunder in Python. So dunder init dunder, and we give all the variables here, the basic specification that is required for the object, the rocket object. And this self is important. So this self is a way to convey to Python interpreter that this is actually an object's copy. The class's copy. Once you do this, you will see there is way to create the variable that you can assign as none also. After this, we also create two more methods. So once you create any function inside the class, so you see there is an indentation here. This means that we are inside the class template. So inside the class template, whenever you create a function, it is called as a method. It is a name given for Python functions inside the class template, inside the class template. Here there are two methods, one is launch and another is rotate. And based on the values you give to both the launch and the rotate, various replies will come out of the template, come out of the object, not the template, it will come out of the object. So let me further explain. As we go into this video, we will further understand how real objects that are copies of rocket class interacts. We have a code for that. We will explain that. So the code explanation here explains the same thing which I did right now. Now let us go to the next slide. In this place, we saw the methods were only using the own data. It was not having any interaction with another object of any kind, of the rocket kind or any other kind. It was not having any interaction. But now you can actually make it to interact also. So here I have created a method which allows the one rocket to take the other rocket as a load. Basically, it will allow one rocket to carry another rocket, and it also tells another method tells whether a rocket has a load or not. This is how any real world application will work, right? So assume that you are doing any rocket engineering and you want to create a system in the space, and you want to know which rocket is carrying which load and what is the weight of the overall load and all those stuff. You can simply create it using this kind of template. So that is how powerful Python's class programming is, or class templating engine is. So you have seen the code. The code is a simple Python functions. If you have not come across, if you have directly come to this video from the internet through search, I would suggest that you take a look at a couple of other videos that I am tagging in this video also, or the playlist that this video is part of. You will see the introduction of Python functions, loops and conditionals as two separate videos that will explain a lot about these functions. Classes uses all these concepts and creates a very useful way of working with real world problems. Let us go further. Okay, now you see that the first and foremost idea is we can create two different rockets that I already told. But then we can also make the two instances to interact using the methods that I showed above. So one rocket can carry the another rocket here. So that is how the actual interaction happens. We can simulate this kind of physical changes in the reality using program. This is a very powerful way of thinking about programming. Usually representing something that is happening in the real world into the programming construct is a challenge. But with Python's object-oriented programming that we are seeing right now, this becomes way more simple. With the ability of very different libraries that we are going to introduce next in the couple of next videos, you will see how powerful object-oriented programming in Python is. Here, by just giving a command that rocket1.take load rocket2, we have assigned the load to rocket1. So that is also the assignment in the command looks like as if it is a plain English. So that is the power of using all this command has been written manually by me, and I have not used any other application. So like this, you can also create. Once you understand how it is being done, you can also create. So that is what we are after. So we are going to create the classes by ourselves. Before even we think about classes, in Python, there is something called as modules. Any script that you write in Python, which has a end file name as .py, can be imported in another function, another Python script. So for an example, what I am trying to say is that my_func.py is a separate script, and it has a function called print_name, and also has the variable mod_name. These two variables, the variable and the function, can be imported into another script, that is your_script.py, by using import my_func. So if I do this, after that you can use this dot operator, my_func.print name, that will print this is a module. So okay, there is a typo here, so it will be there is a module. And if you actually try to say print my_func.mod name, it will print this is nice. So basically the module is kind of like function, but kind of like class. But the major disadvantage is that in case of modules, you cannot make any kind of copies. So you cannot change anything in this variable name. So once this function my_func.py file has been created, every time you can only modify this file, but you cannot create a copy. So if you are going to create a copy, you have to create multiple files. But in case of classes, what happens is you don't need to have this file at all. The entire object template resides inside the Python programming construct or the execution environment. So you don't need to have any files. All this object class representation is basically it's inside the processor and the RAM. So you don't need to worry about creating a file. So that is the difference between using a module and a class. Okay, so you understood the basics of module and the difference of class. What we have done right now is, by using the basic introduction that I have given now, we have taken the first steps into the class creation and object-oriented programming concept in Python. However, we have to go a long way with this concept. It's not a one step. This video is not going to give you a mastery, but this is going to show you the basics. This is going to show you what is possible, how to use it, how the application is of the class templates. But now what we are going to do next is we have to read a lot of code. Ensure that you try to find out other people's who have written code. You can go to kaggle.com, you can go to codewars.com, you can go to Stack Overflow, and you can ask questions there. Check their code, how they are written using functions, using object-oriented programming, etc. And try to execute them on your own Python terminal and see how the output comes. This is an exercise which is going to take you from zero to hero. That is really the the only way that you can master something. After you are comfortable, you can actually go to the next step, where we will be going to the Planet Python. The Planet Python, which has continents ranging from pandas to FastAPI, Streamlit, AWS Wrangler, SQL Alchemy, PySpark, and dbt. All these things, all these are libraries that can work with very different applications. Like FastAPI will help you to create web APIs. Pandas will help you to create analysis and data charts. Streamlit helps you to put the charts on the web. SQL Alchemy helps you to work with database. PySpark with big data. dbt also will help you to work with databases. And most importantly, Jupyter Notebook. Jupyter Notebook is the rocket for you, literally. So all these libraries that we are going to look at will depend on your understanding of how the classes work, how this concept works. Because all the libraries that we are going to introduce next will have their own class templates, and they will create the copies of their object, and on that copies only we will work and create our analysis, create our APIs, or whatever application we want. This is what I wanted to cover as a introduction. Now we are going to go into the terminal and see how this class works in reality. Okay, and I have already created the class classes.template.py, and I have already uploaded this file also to the GitHub repo, so you can download it from there. Whatever code that I explained in the presentation, I have used the same code, nothing I have changed. And without even understanding anything, if you just execute this entire script, so if I use Python and say classes.template.py and execute it, you will see that you will see a story. So rocket Solum is headed to moon, direction of Solum is down. You guys must be crazy. I don't know why that came out. Direction of prime is up, rocket prime is ready for launch, Solum has taken a load. So this tells something, right? And it says yes, load is prime. And in case of the next one, no load, prime is free. So obviously if Solum is taken a load and the load of Solum is prime, then obviously prime will be free, right? And these rockets and the names that you see, Solum and prime, are the real rockets that you saw, or at least not the real rockets, the rockets that you, the pictures of the rockets that you saw here. So the script there actually executes whatever I explained in this presentation. And initially when you read, this is not going to be understandable. But what I request you is that type these script by yourself, but try to remove the variables and try to run it and see what happens, what kind of error it gives. And the same way, launch is a function, launch is a method, and try to change the values in this and see what output it comes. Whatever the functions or the commands that I've used is all basic commands like print, return, the string literals that I have used here. Like when I'm using this kind of sentence, this is actually a string literal. What is meant by a string literal? So when a string is enclosed between the single quotes like this with the F here, you can actually put the variable names, Python variable names, inside these curly braces. And when the code executes, the Python variable names will get filled here. So this is a very easy way of working with strings in Python. This is one of the major points you have to understand for understanding this entire code. Like this, there will be a couple of other challenges. Like you may not, what is this angle? What this angle does? What this angle does? Why? What if, elif, and else does? All these are basic logic which has been explained already in other related videos in this playlist. You can take a look at that. But all these things are basic logic and basic variable assignment. When it comes to interacting between two copies of rockets, that is where the doubts will arise. What will happen is, in this case, I am saying that define take underscore load, and I am giving self comma other. This is the method. But if you come down, this is where all the class definition has happened. So whenever we are defining something, we use the class rocket. This is the definition start, and we come down and the definition ends here. So after this, the definition of the class rocket has ended. So all these are class definition. And now here we start creating the copies. So we have created rocket 1 and rocket 2 as copies with the names and all the variables. And then I am starting to change certain things in the rocket 1 and rocket 2. And whenever I do any change, like giving this method command, this command like rocket1.rotate will go, it will actually call rocket 1, that is this rocket, and it will call the rotate method. So if you go up, there will be a rotate method inside. Yeah, you see the rotate method, and it will call the self. Self is the rocket, the copy of the rocket object, and the angle. So angle will be whatever angle I am giving. So here I am giving angle as 150, which is more than 90 here. So that will say that rocket self.name. So here the name of the rocket. Okay, how to find the name of the rocket? So go up, you will see self.name is equal to name. So the name of the rocket is Solum. So rocket Solum is headed to moon. So if you come down, it is 120. If you go to the result, I am going down, I am seeing the result here. I have executed the code, and if you see rocket Solum is headed to moon. So that is how rocket Solum, this is self.name. That is how the code executes. So whenever you see rocket 1 dot rotate, this rotate is part of the method inside the class definition. Like the same launch, turn, all are like that. Now comes this part. This is part where we are interacting, right? So I am saying rocket 1 dot take load, and then I am saying rocket 2. So if you go to take load method, you will see that it takes self and it takes something called as other. This other is again a rocket object, the copy of this template. This is something that if in case in this method, if you just give some other simple variable like a string or a function. So let me show it to you how this works. Let us go into Python. I am going to go into Python. Okay, and I am going to import classes. Okay, I am going to say from classes dot template import star. Okay, once I do this, okay, first of all, you see that once I do this, it is actually executing all the print statements inside the function. This is one of the things that happens when if you import, after importing the entire scripts get executed. So this is something that you need to be aware. But now what has happened is inside the Python execution environment, we are inside Python execution environment. Inside this, now we can create rockets. So if I go and create rocket 1, if I go and create rocket, just a minute, rocket 1. Okay, there is already a rocket 1 here. Why there is a rocket 1? So if I say rocket, there is already a variable coming, and if I rocket1.name, you will see I am getting, there is already a name called as rocket1.name here. This is because I have imported the entire classes.template as a module into my Python execution environment. This is the benefit. At the same time, it can be very confusing also. If you don't understand this, it can be confusing. And in certain cases, this is called as polluting the environment also. Okay, what is polluting the environment? Whenever you are going to execute the Python code, what happens is you will have an execution environment. And inside the execution environment, there should not be any variables that you are not aware of. Variable is like rocket1. Rocket1 is a variable, or rocket2 is a variable that I did not know that it was already there. So rocket2 is already there, and rocket1 is also already there. So if I just place the name, type the name rocket1 and plus enter, it is saying class template. Class template is the name of the file dot rocket object. So rocket is the class name and the type is object. At this is actually the address inside the processor or the registry where the object is stored. This is how you find the address. You will not be using this. You don't need to know to this level, but I am showing all these things because we are going to create rocket 3. Okay, this is why we actually came in, right? So now we can actually create rocket 3 from here, and we are going to say terminal. The rocket 3 name is terminal, and the size is 158, height is 158, the weight is, let us say, 3268, and the diameter is, let us make it as slim as possible. Let us make it 58. And I'm going to press enter. Rocket 3 has got created. Now, if you want to if you want to check what are the methods available with rocket 3, so you have to just type rocket 3 like this and press dot. After that, press tab. Just press tab twice, and you will see that all the methods and the variable names comes out. So if, for an example, if I type height and if I press enter, you see the height of the rocket is coming out. And the same way, if I actually check, if I check whether have load, it will actually return no load. Terminal is free because the name of the rocket is terminal. And if I say rocket 3 take load, and if I say I give the name of the rocket 1. Now if you press enter, it will reply terminal has taken a load. And after this, if you say rocket 3 have load, yes, load is solo. You see how the object is object rocket. We created it here. We created rocket here, terminal, and after that we step by step moved through the process of checking the height, checking whether it has a load, then we assigned it a load, and then we again checked whether it has a load. This is how the real world application will work. And now think what kind of real world applications you can design using this kind of templates. Stay tuned for next couple of videos where we will start delving deep into one of the most interesting series of libraries in Python, which is very, very important for your journey to become a data engineer or a data analyst. Because all these libraries that I am showing here is by default required. I will be also covering a couple of other libraries which is related to databases like psychopg2, as well as basic libraries that comes with Python that will be useful for you also. But these are the major libraries that you must be aware of. And Jupyter Notebook, we will look into that in detail in the next video. I will start introducing that. All these things will come next, and stay tuned for that, guys. This is a very short introduction about how to create, how to work with and master Python classes, what are the problems it solves, how to actually think about the classes visually, and look at some of the code and create some interacting. Yeah, this is also one of the points I forgot to tell, that you can actually create data structures using these copies of objects. So like, this is something that I have to show it to you. Let me go back to terminal, and we already have 3 rockets with us, rocket 1, 2, 3. So if I say rocket list, and if I go here and if I actually create a list, rocket 1, rocket 2 and rocket 3, it will actually create a list. And if you go ahead and check the list, If you press, I mean, if you just check it, you will see it is made of 3 objects of rocket copy. So here, as I explained in the presentation, let me go back to the presentation. As I have told here in the presentation, you can create the data structures using the class objects also. This way of thinking about the copies of the classes or the templates is very, very important as we go forward in our journey towards mastering not just Python, even the real world applications like big data and data engineering. Because in real world, you will be working with files, you will be working with various sensors, various systems, and various databases, API servers. All these things, if you think, are kind of rockets, right? Rockets are very complex, and so is a database until you clearly understand that. And once you understand to work with these objects or these services or these products, then you will have Python libraries that interact with those services. Like as I explained in the so PySpark works in very close. It's a very close support to Spark environment in big data, and so is DBT. This works very closely with databases, and SQL Alchemy also works closely with databases. Fast API works with servers. It creates API servers. Pandas works with very complicated or very informative tables of Excel sheets and comma separated values. So like these, you will start seeing classes and you will start using them in detail in a lot of places. So stay tuned, guys, and stay tuned for the next couple of videos where I will first introduce these libraries and then go in detail about each library per video in couple of days. So stay tuned for that. Until then, take care, guys, and have a nice time.